Okay, we're going to be discussing more about methods. So in this lecture, we're going to be practicing for working with method using these four examples. So the first method that it displays, it's a void method, so it doesn't return anything. It just displays or prints the factors of a given number. So for example, if the number is 12, then it's going to display all the factors, all the numbers that are evenly divisible, like 1, 2, 3, 4, and 12. So we're going to use the loop because we're going to check every single number from 1 to 12. So it starts from 1. We cannot start from 0 because we cannot divide by 0. So 12 comes out of whatever number might be. And then we're going to check, there's a condition here, if num, and then we're going to use the symbol modulus, because that's the symbol we use to check the remainder. So if mod I equals to 0, then we print the number. So print, let's make sure we use print, and then we're going to have a space between the numbers. Okay. Now, let's call the method in the main method to check if we get the expected outputs. So I'm going to call the method factors. And then I'm going to use an example, 12. So let's run the program. So we got 1, 2, 3, 4, 6, 12, and all of them are factors. Okay, so that's the first method. The second method, it checks if a string is a palindrome. So what is a palindrome? Palindrome is when you read the same word or string and it stays the same backward and forward. Like for example, race car. So it doesn't matter if you read it from left to right or from right to left, it's always the same. So how can we do that? Now the first thing we need to do is find the string that starts from the end to the beginning and then compare it with the original. So here let's define a variable, let's call it backwards empty string, and then we're going to start from the end. So we're going to use str.length -1 I higher or equal than 0 I minus minus, and then we're going to start concatenating. So we're going to say backwards plus equal str. You can use either char at or you can use substring I plus 1. So let me put that as well. So that's an alternative, backwards plus equal str substring I plus 1. So either way. Okay. So once you get that string, then you're going to compare it with the original. If str is equals to backwards, then you're going to put the return true. That means it is a palindrome. Okay, and then we're going to put the default return, which is false. That means if it's not true, then you have to return false. Okay, so let's test it. So we're going to go to the main method, and then okay, the is palindrome. So let's check, for example, race car, which is a palindrome. So it should say true, palindrome. Yeah, it says true. Let me just put system out line here so we can skip a line. Okay. Now, what about if I call the method using something that is not a palindrome, like computer? So it should say false because it's not a palindrome. There we go. Okay. So that's the second method. Now the third method, primes only. This method displays the prime numbers only within a certain range. So as you can see, we have a starting point and an ending point. So we want to display all the prime numbers between these two. Now, the easy way is to have a helper method that check if the number is prime or not before you can display them. So it would be nice or easier or efficient or effective if you can have a method. So let's say a method that checks if the number is prime or not. So we're gonna have public static and then is prime, and then we're gonna have a number. So how do you check if the number is prime or not? Okay, a prime number is the one that has only two values, 1 and the number itself, that are divisible, evenly divisible. That's the one. For example, number 2 is a prime number because you have only 1 and 2 that are divisible. The same thing for 7. 1 and 7 are the only numbers that are, it's like you have two factors, okay, or divisors, the 1 and the number itself. So what we're going to do is, so first we're going to check if the number is, if it's less or equal than 1, they're going to show return false. It's not a prime number. Now starting from 2 and up, so for starting from 2 all the way to the number minus 1. Okay. If you find any number where the remainder is 0, then it is false. So I'm going to put if num mod I is 0, then that's a return false. That means it is not a prime number. And then if we did not find any number that is divisible, then that means it is a prime number. So as you can see here, there is a special case. If it's less or equal than 1, it's not a prime number. Now starting from 2 to num minus 1, like for example 7, so you start from 2 all the way to 6, 2, 3, 4, 5. See, there is not a single number that has a remainder 0. So it returns false. It returns true. Why? Because this if statement never took place. Okay, so let's so we did as prime. Now we're gonna answer the question about the method that displays the prime numbers. So that will be easy now. So we're gonna start from I less than end. Okay, let's make sure it's equal. And then, so starting from start all the way to end, if the number, so we're going to call the method that we just created is prime. So if it is true, you can say equals true, or you can just leave it like that. So that means if it is true, then display the number. Okay. So I'm going to put I and then space. So now let's make sure there's no error here. There is one. You cannot find symbol. If n is not n, it's num. Okay. Okay, now let's call the method. So we're going to go down here. And then I'm going to say, what's the name of the method? Primes only. So let's say from 2 all the way to 20. So it's going to should display all the primes. Let's say if we can find it. So 2 is a prime number, 3 as well, 5, 7, 11, 13. So it looks like it is working because these are all prime numbers. There's not a single number that is not a prime. Okay, now the last method that adds the digits of a given number. For example, if you have 235, so it's going to add 2 plus 3 plus 5. So what we're going to do here, first one, we need a variable because we need to calculate the sum. And then we're going to use the loop as long as the number is not 0, because we're going to keep dividing by 10 and then getting the remainder. So as long as the number is not 0, so I'm going to add the remainder, num mod 10. I'm going to add it to the sum. For example, if I have 235, okay? So what is 235 mod 10? It's 5, which is the first digit, 5. So you're going to add it to the sum, and then you're going to divide, so you can eliminate that number. So you're going to have here num equals num divided by 10. So 235 divided by 10 will be 23. And then you start the process again. Is 23 equal to 0? No. So what is the remainder? 23 mod 10, it's 3. So you add it to the total, and then you divide 23 divided by 10, you have only 2. So every time you divide by 10, you are eliminating one digit. Okay? And then at the end, you're going to return the sum. So let's recall this method. So if we have line, so add digits. So if we have, for example, 236. So if we add them up, we're going to get 5 plus 6 is 11. So let's see if we're going to get 11. And sure enough, we got 11. We just need to skip a line here so it does not get mixed up with the previous method. Okay. Or you can add here the sum of the digits of is, so this makes sense. So the sum of the digits is 11 for 236. So what about if we change this number to 1435. So here, if we add them up, you get 1 plus 4 is 5, plus 3 is 8, so 13. So we should get 13 as an answer, and sure enough, okay? So I hope you find this useful. And thank you for watching, and see you in the next lecture.